Hello students, in today's topic we are going to learn about inequalities. The first point is that a less than b, c less than d. Then a plus c is less than b plus d. It's nothing but adding the both inequalities we can get this. For subtraction we cannot do like a minus c is less than b minus d. It's completely wrong. So a minus d is less than b minus c, which we can get it from if we alter the position of d to the left hand and c to the right hand side. See, it's simple. Okay. For example, if you observe c, 3 is less than 5 and 8 is less than 12. In this way, both addition. 3 plus 8, 11, 17. So in this way, a minus d. So here, minus 9 is less than minus 3. Simple. Coming to the second point, a is less than b and k is positive. In this condition, ka is less than kb. There is no change in inequality, like the position does not alter for the inequality. Whereas if you observe a is less than b and k is negative, we can see altering the sign, like if k is negative, so that we can say k is greater than kb. If we observe an example, for example, if you see minus 3 as k equal to k, like it, minus 3 is less than 5, right? So if we multiply this, 9 is greater than minus 15, right? In this way, the change should be there. And coming to the fourth point, this is very simple property. A is less than b and b is less than c. Then we can say a is less than b is less than c. This is nothing but transitive property of inequality. We take a note point here. If a is less than b and b is greater than c, then there is no relation between a and c. We cannot have any relation. So this is important. Next, coming to the fifth point, this will be very useful in many questions. Like we have to use this property. Please remember this, very useful. If a is greater than 0, or else a plus 1 by a, less than minus 2, if a is less than 0. Okay. Next, coming to the values of x square in inequalities. Here, 6th point. If a is less than b, a square is like squaring this a and b, a square is less than b square only when magnitude of a is less than magnitude of b. Okay. Next, x square is less than or equal to a square, then x belongs to minus a to a. Next property, x square is greater than a square only when x belongs to minus infinity to a union a to minus a union a to infinity. Here closed interval. Next, values of 1 by x, like reciprocals, during the inequality. If both a and b have same sign, they're reciprocal. Sign of inequality alters. Okay, like a is less than b is less than 0, 1 by a is greater than 1 by b. See, here a is less than b, but here 1 by a is greater than 1 by b, from the above property. Let us see an example here to prove the statement. 1 is less than 2, 1 is greater than 1 by 2, right? Like reciprocal, simple. In the same way, vice versa, if both a and b have different signs or opposite signs, the reciprocal sign of inequality remains same. Let us look at an example here. Minus 1 is less than 2, right? Here during the reciprocal, minus 1 is less than 1 by 2. It's of course, it's the correct statement. So there will be no change in the inequality sign. Now let us look at the note points. This is for quadratic equations, very useful. X minus b, where a and b are roots, as you know. If this quadratic equation is less than 0, then x belongs to, this is x belongs to a comma b, open interval. Now, second case, x minus a, x minus b. If this equation is greater than 0, x belongs to minus infinity to a union b to infinity. Note the point that b is greater than a. Many people confuse between these points, like if it's less than 0, then x belongs to a comma b, or minus infinity to a union b to infinity. People confuse between these both points, and many questions we do vice versa. So to remember this, a small graph is required. If you observe, the graph of quadratic equation is a parabola, and these points are the roots, right? So let's think this is A and this is B. This is x-axis, right? Therefore, the below the part is less than 0 and above this part is greater than 0. So here x belongs to a comma b. See, less than 0, a comma b, this part. Next, if it's greater than 0, like the upper part, like positive y-axis, we can see it tends to infinity and minus infinity. So minus infinity and infinity, simple. Let us look at some examples. The first one will be x minus 1, x minus 2, x plus 5 is greater than 0. Tell about x, like to where the x belongs to, which part. So now if you observe, there will be two methods to solve this inequality. One is sign scheme method, other one is wavy curve method. Of course both are similar, but still I like to do wavy curve method. Let's see what it is. First, draw the number line and observe when this equation is becoming 0, the points, critical values, we can say that. When x is 1, so here it will be 0, right? Next, x is 2, again 0. When x is minus 5, these are the critical points. Now mark these points in the greatest order, 1 and minus 5, right? Always remember this point. We should always draw the graph from this side, upper part. So now join this in a wavy curve method. So yeah, this upper part is plus, this is minus, of course, this is plus, and this is minus. So now we can observe where in which parts it will be positive, then the equation is satisfied, right? So x belongs to minus 5 comma 1 union 2 to infinity. That's all, very simple. Just the way one point to be remembered is that start your graph from here, the greatest value upper side. Okay.